So as Richard Feynman says, we have to use the word Richard Feynman. Have you heard of him?
No, sir.
Richard Feynman. He was an American Nobel laureate physicist. So Richard Feynman used to say that it is not just grand theories or grand problems that you have to try to tackle, but you have to learn to fiddle with small problems. Play, he used the word fiddle, or play with small problems, gems of wisdom, pearls of wisdom. So these are equivalent to small puzzles which entertain us. Okay, and that's the way to kindling the intellect for even a formidable examination like IITJEE. So let's play with small problems in quadratic equations. You can search in Google Richard Feynman whenever you have a coffee break. So find without actual solution the nature of the roots of the following equations. Try this, please. So solution.
Yes, sir. The roots are irrational or complex, sir.
Yeah, b squared minus 4s is the discriminant. B is 1 minus 4 times 1 times 870.
Oh wait, sorry.
So delta is less than
Sorry, sir. It's real and unequal. The roots. The roots are real and unequal.
Yeah, so it is positive, real and unequal. Right. Okay.
Because it's minus 870. Sir.
Yeah. Okay. Good. So real unequal because this is not a perfect square.
Yes, sir. It comes as 3481.
And real because it is delta is greater than 0. Good. So not form, form, not from, form. uh, Form the equations whose roots are
Yes, sir.
a plus b and a minus b.
Equations whose roots are a plus b and a minus b. So alpha is a plus b, beta is a minus b. Alpha plus beta equal 2a. Alpha beta equal a square minus b square. So equation is x square plus 2ax plus a square minus b square equals 0. Yes, sir. X square plus 2ax plus a square minus b square equals 0. Sir,
Yeah,
x is sorry, the equation is x square plus 2ax plus a square minus b square
plus
equals
2x, plus 2x or minus 2x.
2ax
Why?
plus 2ax.
Why plus 2x?
Oh
I-
wait, yeah, right.
So next, if the equation has equal roots, what is the value of k? What is
If it has equal roots, that means b square minus 4ac equals 0.
yeah, you find k and tell me, come on.
Yes, sir. So x square plus 2 1 plus 3 b equal 1 b equal 2 plus 2x c equal k square b square minus 4ac equals 0. That means square plus 8x plus minus 4k square. A equal minus half, sir.
Okay, let me check. Okay. Next.
Just give me 1 second, sir. Yes, sir.
What is the answer?
A equal minus 7.
How do we get that?
So see, I substitute the value 2 by 3, which is 5 by 3 for x in the equation.
That's
and
it.
Then I solve for
That
a,
is
sir.
right. That is right. That is right.
I should find the other root also, sir.
No, that was a red herring designed to mislead you. Come on, make an attempt.
Yes, sir. Done.
What is the basic idea?
One sec, I'll show you.
Whatever you find, this is the discriminant, right? The discriminant
Yes,
is a perfect square. Very
That's
good.
a b square minus 4ac.
That's it.
That's a perfect square, so the roots are rational.
That's it. That's a perfect solution to. Okay, good. So some small form the equation whose roots come on.
3 plus root 5 and 3 plus. Alpha equal 3 plus root 2 equal 3 plus root 5. So alpha plus beta equal 6. If on alpha beta equal 9 minus 5 equal 4. X square minus 6x plus 4 equal 0. Yes, sir. Solution to the first one is x square minus 6x plus 4 equals 0.
Next,
b the whole square plus a minus b the whole square by a square minus b square. Alpha beta equal 1. Equation is x square plus 2a square plus b square by x square minus b square x plus 1 equals 0. Yes, sir. So the equation is x square minus 2a square plus b square by a square minus b square x plus 1.
Yes, what is the trick? The main idea, alpha plus beta.
And alpha beta. Alpha plus beta is 2a square plus 2a square plus b square by a square minus b square.
Right. And alpha beta is equal to 1. Okay, fine. So with this little soup or appetizer, we continue with the next development of theory. The development of theory starts with a particular example and then a generalization. If x is a real quantity, please close your textbook. If x is a real quantity, prove that the expression can have all numerical values except such as, please take notes, line between 2 and 6. So solution, the solution proceeds simply meaning what? Let x squared plus 2x minus 11 over 2x minus 3 be equal to y. Of course, immediately jot down x not equal to 3 because it's x minus 3 is in the denominator. So then we get Okay, this is note or observe, this is a quadratic in x. Now what are we given? Refer back to the question, or if you remember the question, x is a real quantity, meaning a real number. So what does it mean about the roots or the discriminant of this? It means something about the discriminant is greater than 0, implies 4 into slightly fishy. I made some mistake, hold on. 2x into 1 minus y. Discriminant is b squared minus 4 times 1 times c. The discriminant ought to be greater than 0. So dividing by 4 throughout, 1 minus y whole squared minus 6y minus 11 is greater than 0. Do you know how the scene will unfold? See, now we have gotten a quadratic in y, or rather a quadratic inequality in y. So we will, if we solve this quadratic inequality, we will know the range of y, in fact, which is this given expression, and which is then the solution. This proved that the expression, that means y, lies in between 2 and 6. So then now simplify it. Come on, let's see if you can get the answer. Simplify, get the quadratic inequality and solve it.
Yes, so the quadratic inequality solved I'm getting y minus 2 into y minus 6 is greater than 0.
Yes, so find out the solution. The quadratic inequality is right. Good. Now solve it. Come on. Do you know how to solve them?
No, not inequalities.
Oh, you okay? Okay, that is surprising.
Not quadratic inequalities. I know how to solve
linear inequalities. Okay,
yes, sir.
okay, fine. I mean, surprising in the sense that I thought you had it in your 10th standard ICSE curriculum. I
No,
don't
no,
know.
sir. Hard linear inequality is there.
That's fine. I will teach you. So this is y minus 6 times y minus 2 greater than 0. See, look, this is some real number. This is some other real number, right?
Yes, sir.
And the product of two real numbers is greater than 0 as given here, shown here. Right? When can that happen? That happens only
If both are positive or negative.
case 1, y minus 6 is greater than 0 and y minus 2 is greater than 0, or case 2, y minus 6 less than 0 and y minus 2 less than 0. Can we solve this simultaneous inequalities? So y is greater than 6 and y greater than 2, or y less than 6 and y less than 2. So y greater than 6 and y greater than 2 together tell us y ought to be greater than 6, and y less than 6 and y less than 2 tells us y ought to be less than 2. Now see, case 1 and case 2 are combined by logical OR. So can the two be combined? So it is like this is the solution set, rather I will put it this way. Solution set is y greater than 6 union y less than 2. So it could be written this way, or that is, I mean, the way to describe the solution is 6 infinity open union minus infinity 2. Okay, now done?
Yes, sir.
Okay, so we observe one more thing so this is the way math develops, and physics and computer science also. Observe the expression y squared minus 8y plus 12 equal to 0 is positive so long as y does not lie well, hold on, please be alert. It is the expression, not equation. Does not lie
between 2 and 6.
Does not lie between the roots of the corresponding quadratic expression. Please take the notes in detail. It will help you memorize everything as well as understand everything. Okay, did you copy so far?
Wait, so how does that make a difference? Because both are the same thing, right?
Hold on.
Both the expressions are same, right?
We are talking of See, understand what I'm trying to say. Observe. Y squared minus 8y plus 12 is, let us say, some expression. Okay.
Yes, sir.
And if I input any y value, any real value of y, it will actually, this expression will actually lie anywhere, very roughly speaking, it will lie anywhere from minus infinity to infinity, as y itself ranges over the reals, right?
Yes, sir.
Right. So now what we are saying is that out of this there is a small portion, y squared minus 8y plus 12 is greater than 0 when y does not lie between the roots of the corresponding, or between the roots of that given quadratic expression. Okay.
Yes, sir.
Because y, see, in this case this y will become restricted. It does not lie in between the roots of this y squared minus 8y plus 12. Is it crystal clear now?
Yes,
What is
sir.
the meaning of the statement? Yeah. So now we come to nice theory, and important result or theorem in the theory of quadratic equations, or what we say, just the theory of equations. So case 1, first let me state the theorem. For all real values of x, the sign of the quadratic expression ax squared plus bx plus c is the same as a, except when the roots are real and unequal. Real and unequal, and x lies between them. In between please copy the statement of the theorem. Yes, child, is there any discussion?
1 second, sir. I have another tuitions at 8, so.
Oh, I apologize. I am sorry. I will continue later.
Okay, sir.
Okay, I forget. I am quite absent-minded. I am sorry. Okay, bye.
Okay, bye, sir.
Yeah.